Good morning, my name is Isabel Villar and I'm a lighting designer working at White Architecture in Stockholm, Sweden. First of all, I would like to thank the Swedish energy agency Light Week 2020 organizers for inviting me to give this talk. My talk today is about opportunities and challenges of integrating daylight and electric lighting in the Nordics, expanding on issues already introduced by Nico Gentile in the previous talk, but from the perspective of practitioners. We know that light has a direct impact on energy use and the building's energy performance. It is estimated that electric lighting accounts for 15% of total energy use worldwide and 5 to 6% of global CO2 emissions. Unfortunately, in the building design industry, daylight and electric lighting planning are often treated separately. However, both disciplines address the same questions about through different means. Since the start of humankind, and as discussed in the previous lecture, for millions and millions of years we have been a species that has evolved under daylight conditions. However, since the Industrial Revolution, in a span of 150 years, research says that we have come to spend over 90% of our times indoors. It took actually decades for researchers to significantly prove that this rapid change of somehow disconnecting humankind from the variation and high exposure that only daylight can provide had a huge impact on our health and well-being. And we are affected by light in all its forms. We're affected by daylight, electric light, and even the light of candles. And so are we by the ever-changing characteristics and composition of the different light sources, as well as by the absence of light, darkness. Being exposed to darkness at night is actually equally important than to be exposed to the right amount and qualities of light at the right time during the day. How light affects our bodies is a complex question that we practitioners and researchers are continuing to investigate on. Natural lighting conditions here vary tremendously around the year. We all know that, especially at this time of the year. So just to illustrate the lighting conditions and exposure we have at this extreme latitude of 59 degrees north, I decided to run an empirical test by wearing a wearable light sensors for a year. This is actually me at home a couple of weeks ago on a heavy cloudy day, facing the windows and measuring 153 lux at eye level. Clearly, under these extreme daylight conditions, it is very difficult to meet any wake-up goal at this low illuminance, and this is shown also in the image on the right, with 8% of the wake-up goal achieved on that day. But what can we do, especially now that we are all working from home? Well, instead of proving the saying, the blacksmith home has wooden knives, I took action and made myself a lamp that I like to call my light friend, and have been using this lamp since October, as you can see. The picture on this light is taken just a few minutes apart from the one in the previous slide. Here, electric lighting does show to help compensating to some extent the low illuminance values received from daylight, which can be beneficial for us during the darker months. However, more electric lighting is not the only solution. It is important that under these extreme conditions we change our daily habits. We need to go out for a walk in the morning, take a lunch break outdoors, in addition to using electric lighting to complement and improve our daily lighting exposure. The light levels that daylight can provide are not replicable with electric lighting without compromising visual comfort. Fact is that at this latitude, if in winter we suffer from lack of daylight, in summer we suffer from an overdose of it, like this image pre-corona time at the office shows. In June, it's actually hard to reach a sleeping goal. Daylight levels are too high until past sleeping time. Here, blackout curtains as limiting light trespass from street lighting are both keys. But how do we work with lighting design strategies that integrate daylight and electric lighting in real projects? If we look back at the lighting design profession with its origin in theater lighting, we have been working for years with the black box paradigm, looking at the space as if there would be a dark canvas where lighting reveals bits by bits the different elements creating man-controlled experiences in the space. However, we know that in a period of a year, we have nearly the same amount of hours of daylight as of darkness, and that when it's actually dark, we often sleep. We believe that it's about time that we drive a change of paradigm and acknowledge that we don't live in black boxes, luckily for us, and that any lighting design strategy must include natural light as a crucial part of it. Ultimately, daylight is where everything starts. So 2 years ago, we started to investigate a standard building design process with the aim to identify where, when, and how the question of light, both natural and electrical, should be addressed at the different stages of the process. We also look more in detail at possible workflows between architects and specialists inside the project to create synergies, beneficial and crucial in the process of delivering the best possible solutions, starting with creating a common strategy for light, running daylight analysis, feeding that information into the lighting design concept, choice and placement of fixtures and controls, and then feedback with information the system for energy and CO2 simulations. My colleagues at White have actually developed an easy-to-use tool called Inform, which is a plugin through Rhino for architects to easily analyze daylight at early stages when comparing different building volumes, which already is a big development towards ensuring better daylight in buildings. We then tested this workflow in a bigger project, an office building in Malmö, to be both LEED and WELL certified. Here, daylight assessments were run to comply with the requirement for BBR, the Swedish building regulation, which the building did pass, and SDA, special daylight autonomy targets, stated in LEED and WELL, which the building did not pass, mainly due to the sky at this latitude being mostly overcast, the scarce daylight hours during wintertime, and the low angle of the sun causing glare problems and higher needs for dynamic shading. However, the special daylight autonomy assessment still provided useful information to lighting designers for the placement of sensors, grouping of luminaires, and programming of different light scenarios. Through an automated script, we also evaluated the view-out credit for WELL, where at least 50% of the regularly occupied spaces should have views with a vertical view angle of at least 30 degrees. This evaluation, even though it did not consider the quality of view, it's still very useful in informing the design team about the minimum requirements for view out, which directly affects both the building design and interior layouts. EML targets in the WELL certification depend on points achieved in the daylight enhanced access feature, meaning that the more daylight availability regularly occupied spaces have, the lower EML values from electric lighting are to be achieved. Nico Gentile already explained in the previous lecture more in detail what EML values mean and how they are calculated. Early in the design process, we identified the contradiction between having high amounts of light at eye level and risk for discomfort glare, being this one of the biggest challenges when it comes to both ensuring visual comfort and circadian lighting. Just to assess this in a more reliable and responsible way, we visually assessed over 8 luminaires comparing lugs at horizontal and vertical planes, color rendering, color temperature, and most importantly, visually assessing glare and shadows. We found that this was a crucial step in our design process, and in feeling confident that the choice of luminaire and placements was a responsible one based both on digital tools and visual assessment. After these studies, we were able to define the different lighting principles for both the regularly occupied spaces and non-regularly occupied spaces, as well as ensuring that the lighting design strategy complies with the light power distribution requirements, with the majority of regularly occupied spaces complying with the watts per square meter allowance, with results ranging from 5.4 to 10 watts per square meter. Later in the project, we investigated the impact that changing our proposal with pendant luminaires for ceiling-mounted fixtures will have. The results showed that when achieving the same EML values, the potential for energy savings from a pendant solution versus a ceiling-mounted one was of 20 to 45%. Solutions where circadian lighting is mounted close to the users are to be preferred not only due to visual comfort advantages, but also energy consumption. To summarize, the question of light is a complex one. This illustration shows some of the parameters that play a role in the lighting design process, where users should always be at the center. Do not forget that. Daylight, electric lighting, lighting controls, energy performance, and environmental impacts, economy, the built environment, and visual and non-visual effects of light are all parts of the equation and play a role in the journey of providing the best possible conditions fitted for human needs and that are respectful to our planet. Combining daylight and lighting for health and well-being asks for a different workflow within the project team, where design and verifications for daylight and electric lighting, interior layouts, and the development of the architectural space itself need to be developed simultaneously hand in hand. When trying to achieve circadian lighting with good glare control and optimal energy performance, it is crucial that the lighting is coordinated with the placement of regularly occupied spaces, implying that it can no longer be developed as a homogeneous layer of light across the floors without jeopardizing energy performance and visual comfort. This stresses the importance of maximizing daylight in buildings. Daylight is by far the best light source we have. It is also free of cost, doesn't require any wiring, and is the light source we are made for. Encouraging interdisciplinary work to provide lighting solutions that integrate both natural and artificial light is needed now more than ever. Thank you for listening.